All right, now testing vocal audio. We are coming right up live here in just a few moments. This is John Park, John Park's Workshop, and I'm testing audio. And I'm wondering if you guys have an echo, because I'm trying something out with my audio monitoring. Any echo, or are we pretty clean? All right, sweet. That is good news. All right, well, let me switch on over to, hey, look, there I am. All right, I'm going to pause that music and show you the workshop. Hi, I'm John Park. Welcome to John Park's Workshop Live. The first 2018 edition? No, we started last week. I was just a little discombobulated from, the new year. So, hey, thanks for coming. I think we've got some people over in the Discord chat, and I'm also going to pull up the YouTube chat if you give me 1 second here. And I'm excited to report that I've got a successful split screen going on my iPad for the chat. Finally figured out how they had changed the split screen inside of the, iOS 12 point something. And so now I'm able to pull it up. All right, good. Audio and video. Hey, Noam Pedro. Hey, Stuff with Kirby. Hey, John Schaffstall. Hey, Nate Larson. Hey, Ronald Rosales. Did I miss anyone? Hey, Matambale. All right, I probably can't do that all show long. Did I miss anyone? No. Pete. Hey, Pete Parise. Parise. Hi, howdy. Oh, a bunch of people up here. We start right now, Dinko M. So when do we start? We start now. We start at 1 o'clock. I think it's 1 o'clock. I started a couple minutes ago, so we're good. And welcome to the show. And Nate Larson reports it is -7 degrees in northern Minnesota. Holy hat racks. Sorry to hear that, man. Wow. I won't talk about the Los Angeles weather then, I promise. So I have a couple things I wanted to show you today. So let's start with this Make Code project that I'm working on a little quick guide for. And what I'm going to do is pull up a web browser, and I'm going to share with you the Make Code. So the project here, we had a request from someone who's doing a cosplay of the wind emoji. I should pull that up. I just made a graphic for it, in fact. Let's, I couldn't find a vector graphic of this because it's a Windows emoji and I'm not on a Windows machine, so I actually just kind of redrew it in a vector drawing program. And I'm going to open that up and show you what we're talking about here. Let's see. Wind face emoji. Let's see. What's a good way to... All right, here's a temp one, actually. This is not the one I redrew. But I'm going to show you over in my screen share. There's a screen share. Okay, so there's the wind, sort of scaled up version of the wind blow emoji. So I hadn't paid too much attention to emojis, but apparently this is one now. And they're different in every operating system or platform. So Twitter and Facebook and Microsoft and Apple, they all get a chance to draw some of these standardized emojis. I don't know who ratifies them, but there you go. So that's the wind blow emoji. It's kind of cute. And someone's cosplaying as this, which sounds awesome. And they had asked us about doing a prop. So I came up with this. Let me show it to you. And this is a little cloud that I have. Let me put that in the camera. And when I blow on it, it lights up. Oh, so you can see that's lit up. And I'll blow on it again. And it's going to fade down. Okay, so the way I'm doing that is with a little Circuit Playground Express, and it's got a microphone on it. So the microphone works really well as a wind blow sensor because it makes a lot of turbulence and a lot of noise when you blow on a microphone. So, I'll blow on that to turn it back off. The way that I built the software for that is this Make Code. So if you're not familiar with Make Code, it's a open source project from Microsoft that uses, I believe, Blockly as the GUI drawing of all these little blocks, and your logic for your software is created by snapping together little blocks, which is actually a ton of fun. So to build something like this, I'll show you what my process was and how this works. So you can see, yeah, along the side here we have a bunch of different categories of blocks. So the way I'm going to do this is actually I'm going to delete this forever block. And what I like to do is first create a sort of initialization or startup block. And what I'm doing when I start up is I'm going to first just set the brightness to 0 on lights. So let me grab this out here. And the lights in this case and brightness, all of these are shorthands for the NeoPixel ring. But you can also add other, you can plug in other NeoPixels to a Circuit Playground Express in order to extend your project. So I'm going to set this brightness to 0, and I'm also going to create a few variables. Let's see, will this make sense? Yeah, sure. Why not? So I'm going to create some variables here. So in this make a variable, you can click the name of it, and what I decided to do was create a max brightness variable, and I'm going to pull out a set item, which I can now switch over to that new variable that I made. Pop this in here, and so this way I can set what the maximum brightness is, because the NeoPixels on here are really bright. I'm going to do, let's say, something like 100. And so then I'll be able to use that value elsewhere in the code when I ramp up or ramp down, but I won't have to change that number in a bunch of places if I change my mind about the brightness. So this is at the top of the code. I get a little variable that allows me to set that pretty easily in one place and then forget about it. The other variable, I'm going to create a couple more. I'm going to create a fade variable, which will start off as 0. And I'm going to create a variable to keep track of if the thing is lit or not, because remember, I'm blowing on it to light it, and then I'm blowing on it again to darken it, and there isn't an easy way for the board to know what state the LEDs are in, so I'm going to keep track of that by flipping this little bit back and forth that's called lit, because this project is lit, yo. So on start, I'm going to set lit to 0 because it starts off not lit. I think that's all I need. I see an extra piece because I'm looking down at the last one I did, and I think I'll ignore that. So now for the main loop, instead of doing a forever, whoops, let me get my loops. Instead of doing a forever loop, something that just continuously happens, I'm actually going to wait for an input, which is really conveniently, we've got this one here called onLoudSound. So well, let me just check my chat for a second. Oh, good, no one's yelling that you can't hear or see me. I should get in the habit of checking that every once in a while. So on a loud sound, we can do something. And in this case, you could just light the lights, set the brightness up high, or change the color. But we're actually going to do something a little fancier than that. In fact, I will start off with this little piece of logic I created, which was the if statement. And what this is going to keep track of is if I'm in this lit or not lit state. So I'm going to start off with if, oh, I'm going to go get a, let's see, where does this guy live? Is that a, I think it's a piece of logic, yeah. So here's a comparison. So I'm going to compare, get my variable for lit. So if lit, I can overwrite that little block there. So if lit is equal to 0, then do something. So this is when it's off. I'll blow and it'll go on. Otherwise, it's going to have the opposite behavior, and I don't need to re-enunciate that. That's sort of a given in here. If lit isn't 0, then it'll do the other thing. So first thing I'll do is set all the pixels to white. I could actually probably do this elsewhere, but this is how I did it, and I know it's working, so I'm going to do it. So we'll set all the pixels to white. And then I want to fade up. So to fade, I'm going to use a little for loop. And so this one right now is, it defaults to this one variable called index that's always there. I'm actually going to use, remember I had created this fade variable and set it to 0 initially. So I'm going to drop that in. And I could have used index, but I wanted a memorable name here, so I'm calling it fade. So I go to my variables and I pull in, oh, I don't need to do that. I'm a liar. I can use this drop-down list. So I'm going to choose fade from there. And I'll keep this here because I will end up reusing that variable. So fade from 0 to what brightness value do I want? And I could type in a number here, but remember I created my max brightness variable. Whoops, that doesn't go there. That didn't make sense that it allowed that to go there, really. So for fade from 0 to, in this case, 100 is what it's going to do. So it's 100 steps of doing something. And what I want it to do is increment my brightness. So I'm going to drop another brightness in. And you could go and grab that from this category palette here, or you can right-click and duplicate blocks that exist, which is really convenient because you start to reuse a lot of the same blocks in your code often. So I'm just going to duplicate set brightness and pop it in here. By the way, I think they updated, it used to be when you would duplicate a block, you would often get all of the blocks that were below it, and you'd have to peel off some and delete them. So I think I like this better. There may be a way to do the old behavior. I don't know. Sometimes you want that. So for this 0 to 100 on each step, I want to set the brightness to whatever the fade value is. So it starts out at 0, and then when it iterates through one time, it'll now be at 1, 2, 3, 4, 5, up through 100, which is my max brightness. So I'll set the brightness to fade, and so that it doesn't happen too quickly, I'm going to do just a little bit of a delay. And so I can do that with this loop called pause. I say I can do it with this loop called pause. Come here. Click him. There he is. And I will just set that down to like 15 milliseconds. Super little fast pause in there, but it doesn't flicker or blink, but it slows it down a little so it's not too quick. So now what this is going to do is it's going to brighten the pixels up to their max brightness there, and then I'm going to pause for a moment. And the reason I do this is that sometimes if you're blowing on the thing and it lights up, it could be that it gets finished with this loop while you're still blowing, and then it'll immediately blow itself back out because it's always listening for the microphone, this on loud sound. So I'm going to put a little pause in here so that it doesn't happen too quickly. So I can duplicate that pause that I created and just give it 1 second. So that's going to be yeah, 1 second or 1,000 milliseconds. And then I'm almost done with this section of the if, except the last thing I want to do is I want to flip that bit of, remember up here I have the if lit is equal to 0. So that if I left it like now, like it is now, it would always be in that state, and every time I blow it would try to go from 0 up. But what I want to do is flip that value. So I'm going to go to variables and I'm going to grab another set item to, except instead of item, I'm going to choose set lit to 1. And this is a pretty common way in programming to keep track of state of something. So I've done something to change the state, so now it will permit whatever happens in this else statement the next time we go and blow. Now, the cool thing is that I can duplicate pretty much all of that code and then make a few changes to it. So I will duplicate the, oh, I don't need that one actually. The pixels can stay at white. And you know what? I think I will change my mind. I'm going to set that up in here. We can set that at white at the beginning because we've got our brightness at 0. It's not like it's going to turn on. So I don't need that bit, but what I will do is duplicate this for fade, and it does duplicate the contents of it, the sort of children of that, or the things contained within that block. So now what I'm going to do is, instead of fading from 0 to 120, I want to fade from 120 to 0. And there's probably a few ways to do this. The way I came up with it was to use a little bit of math. So you've got this little math block, and I'm going to grab a 0 minus 0 to start with. And I'm going to set the thing that I'm subtracting from to be the max brightness. So I'll duplicate our friend max brightness. And the thing that I'm subtracting from that number which is going to start out at 100 right now, is the value of fade, which is the thing that's incrementing every time. So if that makes sense, we start out with 100, and then the first time through the loop, we're going to subtract 0 from it. And then the next time through the loop, we're going to subtract 1 from it, and on until we basically get down to 0. So it's there's maybe better ways to do this, but I basically needed something that allowed me to have a negative increment starting from a high number and dropping down. So I'm going to duplicate fade variable here, and whoops, let me grab this whole little collection. There you go. And replace, oh, that didn't work. Go up there. He doesn't want to go there. Get in there. Set brightness to, all right, this is just a matter of dragging to the right spot. Do I have it? I don't have it. All right, why doesn't he want to do that? It could be where I'm dragging it from. Nope, that's not it. There it is. So I was watching for that thing to light up. Maybe it's the left end of the block that works. Shoo. Okay, so now the brightness will be starting at 100, because that's what it was left off at from the last one, and then taking away these incrementing numbers, so it'll go from 100 to 0. The pause can remain the same. I'm going to duplicate this other pause, which is going to prevent, it's almost like debouncing. It prevents it from rereading the loudness sensor too quickly. And then the last thing is to flip that state again. So we'll have a dark set of pixels at this point, and the next time we blow, we want to satisfy the condition up here of, let me zoom out a little. If lit equals 0, yeah, that'll be true again. And that's it. That's the whole code. So if I want to upload that to the device, you know what? Let's see, what's our time? 1:16. Yeah, let's do it. Okay, so I'm going to give this thing a name. We'll call it puff. No, what is it? Wind emoji. And I will save that. It's going to be a UF2 file. Do you see that? You don't see that because I'm screen sharing just that one app. So trust me, it's asking if I want to save a file called circuitplayground-windemoji.uf2. My answer is yes. Yes, I do want to save that. And I'm just going to put that in my downloads directory. And then here's the Circuit Playground, which had the previous code on it. What I'll do is just press the reset button once, and it'll go to steady green, and that means it is in bootloader mode and it's ready for you to copy code to it. So you could, if you had this, if you're working in Circuit Python, you could be dragging a UF2 that is the latest build of Circuit Python on here, and then it will go into sort of that USB drive mode where you can start saving main.py or code.py. But in this case, I'm sort of overwriting the flash. I'm reflashing it with this wind emoji. So let me open up a Finder, and I'm just dragging that Circuit Playground wind emoji file to my cplay boot, and you'll just see it flash here. Let's see the boop, 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 and it just finished, so it just got that code. Let's see if it works. It does. And blow again to turn it off. And just to prove that it's actually working, let's change the color of that. Let's make it blue, how about? So I'm going to resave the file. I'm going to press this button so that it's ready for flashing. The save is taking a second there. Why? There it goes. I'll overwrite the old file. Downloads, yes please, replace it. And I'm just opening up a folder and dragging downloads to Circuit Playground -wind emoji UF2 to cplay boot. It'll flash. Ready? It's blue. Oh, I kind of like that. So here's my little diffuser I'm using. Ta-da, I'm wind. So that is it. So I'll see if anyone has any questions or thoughts inside of the various chats. Let's see, where'd my YouTube chat go? This is a lot of Windows management. I've been a 2-monitor guy for a long time, but I feel like it might be time for 3, because geez Louise, I've got a lot of Windows all over the place. Okay, here's YouTube. Let's see. Ooh, Toddbot, our good friend Todd. Well, I won't say your real name in case that's a secret, but if you Google Toddbot, you'll find out who he is. Toddbot's over in the YouTube chat. He says, you're learning syntax after a fashion. I've seen a lot of newish coders not understand the concepts of encapsulation and code blocks. This interface makes it super obvious. Yeah, I'm guessing just from that and a couple other comments that people are kind of curious about why you would use make code, or if you're too advanced to use it, don't. It's great for people starting out. It's also great for a certain type of thinking. It's a little bit like flow charting out software that maybe if that software isn't going to do it, or you get to a level of complexity that's too great, you can jump over to Python or Arduino, or in fact, I don't know Java, so I don't, or JavaScript, which one is it? Someone correct me. Todd, you'll correct me. If you look at, there he is. If you look at my code here, up at the top in make code is this little convert to JavaScript. There's the answer, it's JavaScript. If I switch over to JavaScript, it's going to make some machine generated JavaScript, so you know your mileage may vary when things are coded for you. I don't know if this minus button works. Oh, it does, good, so it can scale it down a little. So you can see here, this is really helpful if you're starting to learn to code and you begin with logical thinking of a block-based interface, and then you start to peek over here and maybe start coding by typing. This is a pretty cool way to learn the relationship between that visual organization of the logic and then the syntax of real code. So I'm sure that's a religious debate that people will enjoy getting into over in the various chats. I'm going to stay away from it and just say you've got lots of options, so check it out. Or show it to someone who's new and interested in coding and is visual, because it's pretty cool for visual thinkers. So that is my wind emoji thing, and a couple other things. I've got still to build a case for it of some kind, so I might just 3D print a small case that holds this and keeps you from touching it. I don't know if you can hear this. No, yeah, a little. There's like a little interference when you touch the A0 pin. You can. There we go. You can hear that a little bit. When you touch the A0 pin on the CircuitPython, which is connected to the audio loop of the onboard speaker, you get feedback. So to avoid that from happening, I think putting it in a nice little case would be a good idea, and then maybe some Velcro to just set your puff of cloud on. By the way, I'm sure there's a lot of sources for this kind of stuff. If you just go to the craft store, you'll find batting or stuffing. We have a couple of dogs who love to destroy their dog toys, so that's just pulled out of the guts of Lammy, or I think it was Lammy, poor Lammy. But I have a ready source for this stuff. It's also useful for speaker baffling if you want to improve the sound of a homemade speaker where you've put a speaker inside of a box, stuff it with batting. So that's the wind emoji. Now, for something a little different, I'm going to head into fabrication of our coin box. So let me head over to the workbench here and click back there and there and there. Okay. And by the way, I see that some people, maybe C. Grover, had some comments about other ways to do the brightness thing. So I look forward to checking that out. I always like to check out the chat log after, because I miss 90% of it while I'm up here talking to you. But it'd be nice to check out some other suggestions people have for doing that code. And I'll be doing a guide on that, so I'll be sharing that, and you can, with the make code, we can embed it in a page, so you can have a live session of it, or you can edit it with a URL and change it and publish it to share it, which is pretty cool. So here we have the coin box. So you might remember, you can see this in the overhead, point that at the camera. This is the coin box that I made to add quarters to the Picade. So if I drop a quarter in here, if I can see it, listen to Miss Pac-Man, she'll talk. A walk. So that added a quarter. I've now got 12 credits on Miss Pac-Man over here. Oh, I just started. I'm playing. Let me get out of there. So Coinbox last week was just sort of sitting out there on its own, and you can see I've now built this enclosure for it. So I wanted to go over how I made that and take it apart a little and then put it back together for you. So let's start off with, let me do some desk rearrangement here for a second. And if I raise this camera up a bit and switch over to it for you, let's do that one as the main camera. Oh, are we not live? Is that not working? Let me click back. There we go. Okay, so there's the down shooter camera. And I'm leaving this plugged in, so bear with me a little bit. So here you can see the side of the coin box. I'm going to pop this open. And this one's actually the temporary one. I tweeted about this. I like to prototype stuff in cardboard. Even though it wasn't exact thickness of the material I'm using, it's still very forgiving and fast to cut on the laser cutter, is what I used to make this. And this is an Adafruit box. So Adafruit boxes make really nice enclosures, and I love the way cardboard cuts beautifully and easily. So there's my coin acceptor inside of here, and if you take a look at the way I've got this set up, you can see I built a little front panel that I cut a rectangle out of to fit this, and it's actually a slightly strange shape, and I'll show you why in a second. And then there were 4 screw holes in the coin collector, so I just have some M4 screws and nuts in there holding that in place. I also have some quarters in there to collect. By the way, again, I'll mention, don't do this to make a profit because you'll go to jail, unless you wrote the games that you're playing, but I, as it turns out, did not write Ms. Pac-Man. So this is also not, I didn't build this to be super secure. It's more of a fun thing. You get some tokens or you get some quarters, whatever you've registered the coin collector to use, and people can use them to add lives. And then I can just reach in and pull them out. I don't have it all locked up in this thing. Someone could smash pretty easily. I have new respect, actually, when I think about it, for people who make real arcade cabinets that need to endure thousands of people bashing on them and trying to yank the coin boxes over. Those things are really ruggedly built. This is not. You could smash this. It's just acrylic. So here you can see I've made a little hole for my wiring to go through, and then these 2 slots, a little bit for grabbing the quarters, a little bit for making it easier to assemble, because I needed to reach in there it was easier to reach in there and grab one of the nuts. And here's the real side panel. So I'm going to set this on, and if you take a look at, let's see, is this the right one, or is it, I can't remember which way I did this. That's closer. Yeah, it's the top. I made them symmetrical as far as the holes for joining it together goes, but not so for, let me refocus this, sorry. Not the case for these little vent holes. I actually made them a little closer on the top and a little lower on the bottom. So no reason, just style points. So you'll notice a lot of times when you look at laser cut stuff, and I'm going to go grab, here's that little Neo Matrix display box that I made. I had made a wood version and then the acrylic version. So often what you'll find with this type of joinery, oh wow, my exposure is set way high. Let's fix that. Exposure, where are you? There you go. That's a little more reasonable. Sorry about that. You will see this type of finger joint, which is similar to other types of wood joinery. And it allows you to create something that's cut in 2 dimensions only and is of uniform thickness, and then join them at right angles. That's generally what you do with these kind of boxes. There's some exceptions, but you'll end up with things that need to be sanded and glued and fixed later, because the 2D cutters, like a CNC or a laser, just work on these two axes for cutting, basically. So that's one great way to build stuff. I just wanted a different look for this, partly to match the look of the Picade, which is also laser cut. It's made of laser cut MDF and medium density fiberboard. And I actually realize now it would be good for me to get some 1/8 inch or 3mm MDF. I think actually this might be thicker than that. Yeah, that is thicker than that. It might be 1/4 inch. It'd be cool to use that and then paint it like with some truck bed liner. It's a spray paint that has sort of a rough texture to it. It's a little rubbery. It's similar to what they have. These guys powder coated them. This is by Pimeroni. They did an awesome job with the case. But I decided to do this black plastic to match, and instead of doing the finger joining thing, I'm doing this other type of joinery that's another popular one in building this kind of stuff, which is, and I can't remember if there's a better name for it, but I just call it a captive nut. It's a screw and a captive nut. So if I zoom in here, you'll see, I said if I'll zoom in here, there we go. Okay. And I'm going to lower this. This show is all about a lot of camera adjustments, right? Right. Let's focus. It doesn't want to focus. Come on. I think I'm too close. Try that one. Well, I think you can see that. Yeah. So what I have here is a nut and a screw. I'll take one of these off entirely. And you can see the idea behind this is that you thread a screw on, a nut on a screw, and then it goes through a hole in one piece that's at a right angle to the next piece, and then the precision cutting of this hole means that the nut can't rotate, and so now you can tighten and it pulls the two pieces of work together. So that's a really great way to do this type of case. So I'm going to hop over to the computer for a second to show you some tips for building that inside of a CAD program, and then we'll come back and assemble that the rest of the way. So let me switch cameras here. And I'll step over to the computer and take you through how I built that. Andy Calloway says, AdaCoin, an alternative to Bitcoin. Yeah, there was some funny stuff going on the Ask an Engineer chat yesterday about Bitcoin and MakerCoin and all that madness. So let's see, let me pop this up and I'll pop up the window with Rhino in it. So you could make this sort of thing in any CAD program you like. You could even make it just with 2D drawing in a vector program like Inkscape, which is free. You just have to do a little bit of planning and thinking in 3D if you're using a 2D only software. But I like the 2D, 3D nature of Rhino, and it's something I've been using for 20 years now, so I'm very comfortable in it. So of course it would be a great Fusion 360 type of thing, but I just haven't gotten off my butt and learned that well enough yet, so I rely on Rhino a lot. So the way I did this was I took the calipers out and did some measurements of the coin collector, and if you see here, I just made these little curves, oops, that are the shape of the coin collector and the dimensions roughly of it, as well as the, I think I've got that piece here. Yeah, that little red piece is the front plate. And I measured out where these holes would go. So based on that, I created something large enough to hold it all. And then I started out just with a box. And then I sliced the box up a bit, punched some holes in it, and then I started thinking about how to do the captive nuts and where they would go. And so what I did was I created these little objects that were the dimensions of my nuts. So I actually went over to the McMaster Carr website, and let me hide these guys for a second. I'll show you. Oh, that guy's on that layer. I don't need him anymore. There is the screw and the nut. Let's pull them out. Oops. So that's the CAD. It's an IGES. I downloaded it in an IGES format, but they have about 4 or 5 different model formats of the parts that you buy at McMaster Car. So I got the exact screw. It's a M2.5, 16 millimeters long, and the matching nut to go with it. And it's kind of a nice reality check to bring in the real model inside of the other stuff that you're fabricating from scratch, so that you know that your scales and proportions and measuring is all adding up. It's kind of a relief sometimes when you bring in a real world object that's precisely engineered, and you can then compare your modeling work to it. So I took that as my guide, and then constructed, if we go to a little, let me grab this curve here and go to a right view, you can see I've got a little cross shape that I built that would cover a little bit of overage so that I could go through the nut a little bit of the end of the screw. You can see I've actually built it very, very close to the same dimension, just a little bit of wiggle room here. And with laser cutting, you have almost no kerf, which is the material that's lost by the cutting tool. It's really, really thin, so you can, in many cases, model things right up to the line of the thing that you're trying to fit inside, and that tiny little bit of kerf will allow you to fit in there with no wiggle room. So that's another way you could do it. But the nut is hexagonal, and so this is 2 flat sides. They're going to run into the plastic before they go anywhere when you tighten this. And so that's this dimension, or this direction here. And then if we look at, let me open up. So here's one that I used to cut, and I just made it extra wide so that I was sure it would fit. And sorry, I don't have these things on a lot of easy layers, so I'll just move some stuff out of the way. Oh no, where are those guys? Let's find them. Let's see. Yeah, I didn't organize this that well. I built this. Oh, there we go. So these are the little cutters that I used, a Boolean operation, a Boolean subtraction, to cut out these M4 screw slots here, and then I had a set of them for the sides. Now you'll ask, why am I doing all this in 3D? Because in the end I'm going to do it in 2D, and it's mostly just a reality check so that I know that things will fit well once I cut them, so I don't have to do a lot of trial and error in fabrication. So I know that everything, let me hide this again. I know that everything fits well. Then I take all of this and I flattened it out on the ground. And let's see, where are the versions of this? 3D to 2D. So I actually took my whole box apart and just laid it out on the ground, duplicated the border edges of it, and ended up with these. Ultimately, let me go to the top view. There we go. These components. Now, since I was going to be cutting out of a particular dimension of material, I laid out a 12-inch by 12-inch square so that I know I can pack the stuff that I'm cutting into the sort of most efficient use of the material. So it turns out I was able to fit the top and bottom panels flipped sideways, and the front and back panels all out of one piece, and then the 2 side panels out of a second piece. Just to show you, because I think it's kind of interesting workflow, and I've shown this before, but you can see here I actually originally had built this with just a rectangle in place here. So I'm just going to go back to that. And when I did that, I ran into a problem, and that was the little side bump. I don't want to pull it all out now, but there's a little side bump, and you can see here, this was one of my cardboard prototypes. I had to cut out a little spot there to fit the coin collector, just because I hadn't measured quite exactly the width at its widest point. There was a little bump out in a screw. Let's listen to the plane go by here. And I'm going to get a sip of water. By the way, I saw Todd Bott mentioned in the YouTube that I was talking about the truck bed liner. So truck bed liner is a good one, or Plastidip. And that's the stuff people spray their entire cars with, and you can just peel it off later. It's pretty cool stuff. I actually went over some parts on my Jeep with it, and it I have a nice matte black finish on some stuff that you can actually just peel away later if you want. And that Plastidip would be kind of a cool thing to paint MDF with too, I suspect, but I haven't tried it. So I went back and revised this, and just if you're interested, I did some measurements. Let's pretend that I'm doing them now. And here's one way I work is I'll just I'll snap to something somewhere, and let's say I had measured, I need to be, I don't know, 12 centimeters down from the top there. I can enter that value in, and I get a little 12 centimeter line, and then I can create that little thing that juts out, and I can create it just snapped to this part. Now I don't need this part anymore, and I can move this thing precisely by snapping from here to here. And then I use a type of a Boolean operation. Actually, this thing started out as a real legitimate rectangle, so let me return it to that state as a real legitimate rectangle. I've just typed in join. You'll see the commands I type show up here. And now I will turn those into one thing with a curve Boolean. And literally I just type in curve Boolean and hit enter, and it says click the parts you want to keep. I want to keep these things, and I want to delete all of the curves that went into it that I don't need. And now I end up with the type of curve that you saw me with before, except in the wrong spot. So I'll undo that and place that here. Now, one thing I didn't do yet is you'll see I've got some graphics down here at the bottom, and these are going to be raster etched into the plastic. And so raster etching is a secondary mode in the laser engravers and laser cutters, where you can use vector lines to cut stuff, and you tend to use raster images, not always, but you tend to use raster images if you're trying to engrave stuff. So you can take a photo of someone's dog and laser etch it into a piece of granite so they can set it on their mantle or whatever. And the etching process goes back and forth like an old dot matrix printer, just bzz, 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 pulsing the laser. So I created this with a type of a fill called a hatch that gives me what started out as you can see here, I'm going to insert coin to play. So if I start out with text curves like this, but I want to be able to etch that into something, I don't want to cut those, I don't want just lines, I want it to be filled, and a good way to fill that with solid black is to use this hatch command. So I will choose a hatch. Oh, it doesn't show up, sorry. And now I can get rid of the curves. Oh, I missed a part. Hatch. So that is how I went about building the parts for this. And I made the one iteration. I went from cardboard, had that problem, fixed that problem, decided everything else was close enough, or was good, was solid, that I then went and created the plastic one. So let's go and finish putting together that. Oops. There we go. I'm going to go finish putting that together so you can see that come together, and then show it again in use. So let me pop this camera up a little bit. You can see what's going on. And that still looks in focus. Tell me if it's not. Oh, I'm going to pop back over to the chat here. I got my double chat up. And let's see. Oh, can I refresh this page? And yeah, there it is. All right, I'm going to get the inception effect as I see my own self show up delayed on the video here. And live chat, there it is. Oh, I better turn that volume off or we'll listen to... Yeah, there it is. Yeah, there we go. Okay, yep, good. All right, I see no panics. Okay, so let's put this together. So let me know if that's not in focus, I'll check. So that one screw I took out, that's going to go back into this top piece here. You can see I've got a little hole that I made. And I like these little cap head hex screws. They have kind of a nice finished look, and I'll be using the bottom ones as feet unless I put something fancier on there. So, whoops, that's fun. Look, I have a magnet. Let's see if it grabs the right thing. Are these magnetic? Yeah, they are. Why isn't it grabbing it? Or did it fall through? There it did. It fell through one of my little heat holes. There we go. Heat holes, that's the phrase that pays today on John Park's workshop. All right, so let me thread that into there. And you can see I'm going to loosen these so that they'll all reach. These guys should be in good places, yeah. And now this will go on like so. And the main trick of this is to kind of get everyone started before tightening any of them too much. And you can see again why I built this little, oh, sorry, I'm showing you things that aren't there. Move that a little bit. See why I put this little hole in there is at least gives me some of these that I can get without just using ESP or some telekinesis, which is very helpful when you're putting this stuff together, is to use your telekinetic powers. Let's see, why is this one not going in? See that? All right, watch me struggle with this. So this is a bad orientation to do it, but it's a good orientation to show it on camera. So it'd be a little easier if I did this up and down so that the parts don't fall through. All right, we'll put that one in place at least. So you can see I've got the hex nut angled properly, and that one's in. Loosen this one a little bit. See that right? Yeah, I can get a little closer. Huh. This downshooter has decided to stop paying attention to the interface, so I gotta do it the manual way. All right, I'm going to show you, here's the other way to do this, is I'm going to take the screw out entirely of the nut, and then I'm going to drop the nut in. I've got my finger under here to stop it, but I'm going to drop the nut in properly, and then I can go and reach it with the screw. So this is if you don't have access, because I've got these finger holes in here. If you don't have access, you can lay this on its side so that that doesn't fall through. Hopefully it doesn't fall through, and tighten that up. So let's see. This is not the most exciting TV ever produced, so I don't think I will tighten the rest of these on camera for you, but that's actually going to hold. It's not going to collapse. So let's switch to the other camera here. And the workshop camera here. Okay. I can move this out of the way. And there you can see I've got my nice, neat little coin collector. You can see the light inside of there. We've got a pretty noisy drop when the coin goes in. So let's switch these cameras. Hold on. Where's my thing of quarters? Okay. So let's see. Let's put in some fake thing first. Let's find a Canadian one. See it get rejected. All right, here's something Canadian. Does not like it. But here's a regular quarter. And I see, can I turn this around? Let's turn all of this to the camera. The question always is, what's the glare going to be like? And okay, you can sort of see that. So that's kind of loud. So I put a little piece of felt in here just for now, but I think I could put a little drawer or something like that instead to capture the coins and then pull it out. And of course you could build a nice little latch or lock mechanism if you didn't want people fishing their coins out. So here goes a nickel. This won't work. Nope, rejected, but quarter. And a little bit quieter when it drops. So you can see if I actually launch, is that Miss Pac-Man? Let's see. I turn the volume up over here. Or is that Galaga? It's Miss Pac-Man, okay. So drop a quarter in and we'll get a life. But whip, and now we can start. And there's our Pac-Man. So that's what I wanted to show you today for the coin collector and building that type of construction. And this is the sort of whirlwind edition of all sorts of stuff on John Park's workshop today, because since we have a little bit of time, I wanted to show you some of my next steps with the collaboration with Brian Kessinger on the AT-AT. So let's move all this good arcade stuff off to the side. All the geeky hobbies are represented today. Emoji, arcade games, and now AT-ATs. So if you remember, this will just be a tease a little bit, but if you remember, I had the painted one, and Brian's brother actually lent us an unpainted one. So these are popcorn, believe it or not, popcorn holders from Disneyland. And Brian went and did a really nice job painting this one up. So I thought it would be nice to be able to test on this one that hasn't yet been painted, get my electronics working in it, and then Brian will go ahead and paint this one, give it back to his brother, and then I'll put a second set of electronics in Brian's. So this one, I took some screws out from the underside here. There were 4 screws, and then with a little bit of prying, we get the whole top off of there. And again, you can see this is just a ton of great juicy space to use to put the electronics. I had shown a couple weeks ago my little sound card with the audio effects board, the Adafruit audio effects board that I'm using to play back the AT-AT noises. And I still need to figure out the circuit for doing the background music on the MP3 Music Maker shield with a feather. Is one way I was thinking of doing it, so that the feather is receiving the button presses and then sending the effects cues out to the audio effects board and lighting up a light. If I weren't trying to do the lighting up of lights to flash with it, then I wouldn't probably need a microcontroller at all. We could probably get away with the audio effects board or something along those lines, or 2 of them, so that one plays background music and one plays the effects without stopping the background music. But either way, the next step for me is figuring out buttons. So one of my ideas is to use, let's see, should I switch it? Yeah, I'll leave this camera on and I'll just zoom it down a little bit. Zooming, zooming. Ooh yeah, look at that zoom. I like this lens. So here is a little proto board. This is actually meant to go on a feather. It's a little proto wing to go on top of any of the feather boards. You just put the headers into it and you can set it on top of the feather. But it's actually a pretty convenient little board. It has some bridged connections, so there's 2 rows here. There's a bunch of shared pins here for ground and power. And so I was thinking of using these long stemmed buttons. You can hear these clicky clicky. I was thinking of using those and setting them under this ledge here, so that you'll be able to reach up and press one of 4 buttons or whatever we end up with, as well as maybe the power on off. Get that stuff onto there and maybe just put some little standoffs, drill some holes through, put some nylon 2.5, M2.5 screws and standoffs, and this can go right up into there. And check this out. That will actually hide the buttons really effectively, because what I'm hoping for is to not show any evidence of that added electronics. Put this back on. So when that's on like that, this will fit right up under there and no one will see it, but with those long buttons it'll be pretty easy to reach up in there and press those. So that was a very happy accident that the width of this little space is just right to fit that. Pop that off there. So that's my thought. I drilled 1 hole in here already that wasn't there. I put that hole in there. By the way, again, I love using these little reamers on a Yankee screwdriver because you can make a hole much more effectively than with a drill. And then I bored it out with this little reamer that's a tapered reamer so I could get the hole size I wanted. So that hole, the reason that's there is I think that's where I'm going to pass wires up through. So this will need to be off a little bit to deal with the solder points and the standoffs, and then I may run the wires on that backside too so that things that are soldered to the board are all back there. I don't know if I'll try to hide it. I don't think I need to go that nuts with it, but that's how I'm going to go ahead and put 4 more holes in, screw that into there, and then we'll have our nice little, oh, let me go big screen with this actually. Sorry about that. There. Big O vision. So here you can see that's going to hide right under that little ledge there. Could maybe also put it inside of there, but I like having this part detachable and this base being where all the electronics are going to be stuffed. So that is how the buttons are going to be dealt with. Let me see. I've got a little box of parts. Where'd it go? Ah, here it is. By the way, behind the scenes stuff, I'm sure a lot of you do this. I tend to, with projects of this scale, obviously you can't do this when you're building a workbench or something, furniture, or a large chainsaw wielding robot. But when you're doing stuff in this sort of scale, I get a plastic storage bin to go with a project so that I can clear stuff off. So I have a lot of storage bins with projects in them. So this is the AT-AT, where the AT-AT stands. I think I'm going to go with, I was looking at the little 4 ohm speaker here as my speaker, and there is a, I think he's actually currently connected to, this is the Audio Effects sound card that has an amplifier on it. It's not super loud, but it might be loud enough for just, this is for tabletop gaming. And that means that I don't need a separate power supply for a powered speaker or to build a little amplifier circuit or something like that. So let's see if I can fire that up, and I believe I put some effects on that. So let's plug a USB battery. How about, where did I put that? Here's my little, this is one of these power boosts that I took a couple LiPo batteries in one of our power boosts and put together this little sort of phone charger thing. So I'll just power that off of here, and then my buttons would run from ground to, move this to the speaker, what I have on 0 and 1. So that's that little walking effect. So it's a little bit muffled inside of here when you close it all up. That was my concern, is should I drill holes through the bottom so that we get some sound holes or along the sides, or not worry about it. It's also something I got to ask Brian about, what he wants to do with it. So Brian, if you're watching this, please chime in. I'll check the chat. I don't know if he's on. And, oh, it looks like is my chat updating? I think my chat stopped updating. Okay, I'm going to head back over to the chat on my computer here for a second and see if there's any other thoughts and comments. But otherwise, we are getting ready to wrap up here. So, hey, Discord. And there I am. Okay. Ah, yes, okay. If you end up using a microcontroller, what about touch sensors instead? Could be implemented with a screw head showing. That's a cool idea. Yeah, so if we use capacitive touch instead of that, that's pretty cool. You guys are cracking me up. Juicy space, I say. Lots of juicy space. Ooh, tips from C. Rover on, yeah, a piece of tape could hold that nut in place while you're screwed in. That's a good point, too. You could prepare them all with that. Good call. You could even make if you laser cut, this is back to the little T-shaped nut cutout. if you make it a little small, you can heat press it in, and then it's going to be jammed into there. It never needs to come out, so you can prepare it all. So that's another methodology for that. Lots of good ways to build with that kind of construction. And let's see, YouTube, what's up? Oh, you don't see me watching the YouTube, but I'm here. I'm watching it. All right. Cool. Some people are talking about doing 3D prints of the AT-AT, I think. Excellent. Yeah, there's a really cool video a guy shared with me on Twitter of an AT-AT project he built where he's doing some locomotion, which is super impressive. Very cool. Nis says use some acetone to melt it. Oh yeah, you could take some acetone and maybe melt the plastic depending on the kind of plastic you're using. Cool. All right, well, I'm going to continue to hang out over in the chat after the show. If you want to head over to Discord if you're currently somewhere else, like Twitch talking about stuff. I don't think we have too many people over in Twitch or Facebook talking, maybe. But the action tends to be on the YouTube chat and over here in Discord. So YouTube chat will go away. Oh, and we got a great suggestion from ToddBot. Thanks, Todd. Instead of the sound module, we just put a tin can with old screws and nuts and use a gear motor to slowly spin it. It makes the same noise as the AT-AT. That's awesome. In fact, I just have to read that passage. I don't know if you saw this, but Todd, when I was looking at the Sounds of Star Wars book, which is totally awesome, this book talks with, what's his name? Ben Burt and some others. Ben did the sound on the original Star Wars movies. And some other people who worked on the first 3 movies. You go to a page in here, and now I forget where our AT-AT was. Let's go to Empire. It's sorted by movies. Okay, so there's the AT-AT page, and it's got a sound module here, so you can type in the number of the page, the sound effect on that page, and it'll play it for you. And then it gives some info about how those sounds were made. So AT-AT, I think you're pretty close, Todd. Bert knew you'd need some complex metallic sounds for the audio of the AT-ATs, and sent Tom, T-H-O-M, last name Tom, I don't remember his first name, to search for those sounds. He was recording metal shears, giant machines that cut metal into segments. They have a multisyllabic sound and a hydraulic pressure building up. So that, I think, was, yeah, that's the sound. So pretty close to tin can full of junk. And probably that's the right scale sound effect. So I love that idea of doing mechanical sound drum inside of there. Yeah, that book is awesome, and it, I think, is not that much on eBay or on Amazon, especially in the used section. It might be expensive new, but I would look for a used one. It's beautiful, beautifully done. And it's got good audio. So I actually plugged, there's a headphone jack on it. So I captured the audio that I put on the sound chip by running that audio out to my USB audio interface on my computer, a little mixer, a little Alesis mixer. So I ran the sound direct off of there, and the quality is really nice. So thanks everyone for tuning in, and I think we're out of time. It's just about 2 o'clock now, so I will see you next week, same time, same day, Thursday, 4 p.m. Eastern Time, 1 p.m. Pacific Standard Time, something or other Greenwich Mean Time. I forget which one it is. And the music you heard as I'm going to play you out. I'm going to turn up the sound on my little arcade pocket operator, which I super love. So let me bring that up and in. Let me turn on some chords for us here.